In this video, I'll go over two problems from week 6 homework assignments. The first one is question 22. Assume that human body temperatures are normally distributed. Okay, so this is the keyword. We know that this is normally distributed with a mean of 98.23 degree and a standard deviation of 0.61. So we know that we have the mean to be 98.23 and the standard deviation sigma with 0.61. So part A hospital uses 100.6 degree as the lowest temperature considered to be a fever. So if you are below this 100.6 degree, then you are not fever. And if you are above or this number, then you have a fever. Now the question asks you, what percentage of normal and healthy persons would be considered to have a fever? And though this percentage suggests that a cutoff of 100.6 degree is appropriate. Okay, so we have, this is the normal curve. This is the normal curve. We know that we have the mean of 98.23. Okay, and then they ask you for the degree of 100, maybe around here, 100.6. Okay, so they ask you what percent of the normal healthy people above this degree. Now, in order for us to find the area, we first need to convert this to the z-score. Okay, the z-score. So we know that with the normal curve, the z-score has the mean of 0. This is the mean of 0. Now we need to convert this is the x point. We need to convert the 100.6 to the z-score. And we know that the z-score has the formula of x minus the mean over sigma. So 100.6 minus the mean in this case 98.23 over the sigma, which is 0.61. And if you do that, we would get 3.89, rounded to 2 decimal places. Okay, so this is the z-score. So now the 100.6, using the standard normal distribution, the z-score of that should be 3.89. Okay, and now we are looking for a healthy person would be considered to have fever. That means you are looking for the number of the people that that have the temperature of above 100.6, which means we are looking for this area above. Okay, so above here would be considered to have a fever. Now, how do I find the area? Well, we can use the technology to find the area, right? So I'm using the TI 84. So we are going to use the distribution. So second var to get you the distribution. And we use the function normal CDF, enter. Okay, we know that the lower bound is the number 3.89. We are looking for the area. right? This area here. So 3.89 is your lower bound. 3.89. The upper bound you want all the way to the right, So we want a huge number to the right. So I just put the 10,000, right? As long as you get a very large number. And then the mean, it should be 0 because we are using the z-score. And the standard deviation, it should be 1. Now we paste that. Now if you are using the TI 83, you have to enter manually the number. So the first input is your lower bound. The second input is your upper bound 10,000, just to be a huge number. And then comma 0 for the mean and 1 for the standard deviation, and then close the bracket and then hit the enter. So this is the area, right? The area. And we know that we are looking for the percentage. So we have to multiply by 100. And that gives me 0.0050. Now they ask you to round to 2 decimal places, which is up to this digit. Okay, this is 0. So after the 0 is number 5. This is number 5. That's why we round the 0 up to 1, because this is 5, or as long as the number after that is 5 or bigger than 5, you round this number to 1 more digit. We add 1. So that's why we round to 0.01, which is right here, 0.01%. And the next question, does this percentage suggest that a cutoff of 100.6 is appropriate? And the answer is yes, right? Because you have 0.01%. This is very small. This is the very small percent of people that have fever for above this value, 100.6. So that's why it's okay to use this cutoff. Or we can go back to here. We know that the probability that we found earlier, the area, is 5.01 to 5.01 to the 10 of minus 5. If you, this is area here. If you rewrite using decimal point, you would get 0.00005. 1, 2, 3, 4, 5, or 1. Okay, and because this number is less than 0.05, so from chapter 4, if the probability less than 0.05, this is significantly low, and therefore this would be a low cutoff. I mean the good cutoff for 100.6. That means not a lot of people. It's very low to have people above this degree to have a normal temperature. So anything above this degree should be considered as fever area. Okay. And now the last question, the next part. The mean temperature for requiring further medical tests should be this is question mark. If we want only 5% of healthy people to exceed it. Now, the second question, you are given the value that you have 5% of healthy people to exceed this one. This is 5% or 0.05. Okay. Now you are looking for what is this temperature? Or what is the z-score given the percentage, the area? Right, so how do I do that? Now remember, last part, we were given the z-score, we found the area, but now we are given the area, we are asked to find the z-score. Okay, so we can find the inverse of that. So I go to my TI-84 again. I still use the distribution, and then I use the inverse num function. Given the area, find the z-score. Now, remember, the z-score represents the point here, and then the area we want is the area to the right of the z-score. However, for the TI-83 and 84, the area here of the inverse num function is the area to the left of the z-score. Okay, we know that the whole thing has 1 for the area, and now we have this area 0.05, so the area to the left of the z-score, which is the rest, 1 minus 0.05. Right, and now we have to input 1 minus 0.05 because the functions of the inverse num take the area to the left of the z-score. And we still have the mean of 0, standard deviation is 1. We paste that. If we are using the TI-83, we still use the inverse num function. And the first input is the area to the left of the z-score that we are looking for. And then the mean 0, standard deviation is 1. And now we hit the enter. So we have the z-score of 1.64, 2 places. This is the z-score only, but we are looking to get back to the real temperature. We know that the z-score equal to the mean the x value minus the mean over sigma. Now we know the z-score 1.64. We are looking for the temperature x. The mean is still 98.23. And the sigma here is 0.61. So to solve for the temperature x here, we multiply both sides by 0.61 and then we add 98 on both sides to solve for x. So my x should be, okay, so let's do that. We have 1.64 multiply 0.61 and then add to 98.23. So that's give me 99.23, which is right here. So this is the mean temperature that we should use if you want 5% of healthy people to exceed it, to have fever. And that is the end of this problem. The next question is question 25 on the same week 6 homework assignments. So the assess of 4 wealthy people in a particular country are 44, 34, 23, and 18. Assume that a sample size n equal 2 are randomly selected with the replacement from these populations of 4 values. Now, after identifying the 16 different possible samples and finding the mean of each sample, construct a table representing the sample distribution of the sample mean as below here. Okay, so we have 44, 34, 23, and 18. Okay, we have 44. Now, because the sample size is 2, so we can have 44 with 44, 44 with 44 because 44 with itself, and 44 with 34, and 44 with 23, and 44 with 18. And then 44, and then 34 with itself. So 34 with 34, 34 with 44, 34 with 23, and 34 with 18. And then we have 23 with itself, 23 with 44, 23 with 34, 23 with 18. And then the last one, we have 18 with 18 by itself, 18 with 44, 18 with 34, and 18 with 23. Now we see that we have 1, 2, 3, 4, 5, 6, 7, 8. So 16 total. So 16, right? So 16 different combinations of all the two samples. Now we are looking to find the sample mean. Okay. So the sample mean, that means we add them, we divide by 2. Okay. So 44 add 44 divided by 2 is 44. 44 add 34 divided by 2 give me 39. 44 add to 23 divided by 2 give me 33.5. 44 add to 18 divided by 2 give me 31. And then 34 add to 34 give me, divide by 2 give me 34. 34 add to 44 divide by 2 give me 39. And 34 add to 23 and then divide by 2 give me 28.5. And then 34 add to 18 divide by 2 because we are looking for the mean, right? The sample mean. So 34 add to 18 divide by 2 give me 26. And then just keep doing the same thing here. We are looking for the sample mean between two of them. And if you do all of that, you should get all of this number here. Okay, so this is the sample mean between two of them. Now let's go back to our questions. We have 44. What is the probability of 44? Okay. So 44, we know that we have 44 is right here. So 1. Right, so only 1 44. Okay, so that is 1. We have 16 total. So we have 1 over 16. Okay, there are 16 of them. So the probability of that should be 1 over 16. How about 39? 39 we have 1 here, 2 here, only 2. So 2 over 16. We have 34, 1, 34, only 1. So 1 over 16. And 33.5, 1, only one. So 1 over 16. And 31, we have 131 here, 2. So 2 over 16. And 28.5. Okay, we have 1 here, 2 here, 2 over 16. And 26, we have 1 here, 2. So that is 2 over 16. And 23, we have 1 here, only 1 over 16. Oh, this is not 2, this is a typo. 23 add to 44, divide by 2, that gives me, this is 33.5. Okay, so we have 33.5. Okay, so we have 33.5 here, 1, should be 2 of 33.5. So go back to 33.5, it should be 2 over 16. Okay, that is the mistake. And then the next one, 20.5. 20.5, we have 1, 2. So 2 of 2 over 16. And then the last one is 18, which is the remaining number. So 1 over 16. Okay, let's check the answer. Alright, so compare the mean of the population to the mean of a sampling distribution of a sample mean. The mean of the population, remember the population have only these 4 numbers. So we are looking for the mean of the population, which is these 4 numbers. So to find the mean, we add them together. This is the population. We divide by 4. Okay, so let's do that. 44 plus 34 plus 23 plus 18 divide by 4 give me 29.75. Okay, 29.75. And then the mean of the sample means, right? The sample mean is the X bar, okay? So we are looking for the mean of this number, okay? So I add all of them. This is the sample mean. So I add all of them together. I divide by 16 because there are 16 of them. So 44 add 39, add 33.5, add 31, add 34, add 39, add 28.5, and add 26, and then add 23, and then 33.5, and then 28.5, and then 20.5, 18, 31, add all of them together, 26, and then 20.5, and then divide by 16. I should end up with 29.75. The same thing, right? In this case, it happens to be the same thing. So 29 point, the sample mean had the mean of 29.75, and in this case they are equal. Okay, the last question. Do the sample mean target the value of the population means? In general, do sample means make good estimates of the population means? Why and why not? So the sample mean, which is the one that the sample mean is we add all the 16 numbers together, we divide by 16. So the sample mean targets, right? Because they do have the same value. So it targets the population mean. In general, sample mean do make good estimate of the population means because the mean is the unbiased estimator. Okay, so we have the same number, they are similar. Okay, so that's why the sample mean do make good estimates of the population means because it is unbiased estimator of the population means. And that is the end of this question, the 25 from week 6 homework assignments.